HOD ECE department, and I am convener for this program. And this Shadar College of Engineering and Technology is one of the oldest institution in Telangana. We have established in 1995 with the intake of 60 in 1995. Now we are running our department with 120 intake, and we have 2 MTech courses, VLSI system design and embedded systems. So as you are seeing from last 2 months, many colleges throughout the India are conducting faculty development programs. I have also participated many programs, and this is the new experience to all to organize the FDP online, because previously we have done organized many FDPs, but it's not online. It is a new experience for us all to learn new technologies through online, because we have seen AICT, NPTEL, and UGC. Many central government bodies also encouraging students and faculties to attend many programs through online. So it's my pleasure, and I wish all of you learn many things related to embedded systems and robotics from this session, 3-day session. And we are conducting this FDP of 3 days, today, Saturday and Sunday. After the end of the 3rd session on Sunday, we'll issue a feedback form. Whoever fills the feedback form, then automatically will generate the e-certificate to them. Please remember, who are not getting the emails, I am getting many calls and many WhatsApp messages that you are not getting participation link. I have sent to each and everyone. Please make sure whatever you have entered the email ID, because from my known participant who are my friends, they entered the email ID wrong. So I cannot see each and every one email ID, I cannot check. Is whenever you are typing the email ID, please make sure exactly without spelling mistake you type the email ID. In the hurry you may type it wrong, so it may lead to problems to me and to you also. Please, I request you once again, you check your email ID which you have entered. If you are not entered correctly, you are not getting email, then at last you personally message me your email ID, because more than 10-15 student faculties I got a complaint that you didn't receive email ID. And at the end of the session, whenever you have any questions, you can chat on the chat box here, and at that time please unmute your mic. In the middle of the session, please don't unmute. It will create problems to you and to us also. And let me introduce our young and dynamic speaker, Professor Javed. He is my close friend. I know him from many years. He is one of the active participants of and organizers of many FDPs. In these durations, lockdown duration, he has conducted more than 5-6 FDPs through online for his college and for other colleges as a resource person. I feel privileged and happy to be in our association as FDP as a resource person, because I too personally learned many things from him. He's a very good active researcher, and you can say he has a number of, you cannot say that he doesn't have his hand in this field. He is perfect in embeddeds, he perfect in robotics, and he perfect in image processing, VLSI, and he has authored 2 textbooks. And already last year he launched one textbook, Embedded C for 80151 microcontroller, by author Professor Javed. You can see that online also textbook. And he has been invited to participate in the international conference, Malaysia, and to other countries also to participate in so many FDPs and conferences. So I feel privileged to have him here. You may be participating, hearing many FDPs in these futures, but definitely I feel it's a different experience to you, because he has complete practical knowledge in embedded and robotics. And when in his institution to his students, I have seen personally, he is guiding the students completely in major and many projects. Because generally we see that many students will go to institute, will learn from institutes. But he is the person more than 100 students he is guiding the complete projects. Definitely to learn practically and theoretically from this 3 days session. I hope whatever you have questions, you please ask and we are there to you answer. Definitely, it's our privilege to help you. Now I request Professor Javis sir, please continue this session.
Yes, sir. Good morning, sir.
Please make video of everyone, sir.
Hello, sir. Can you hear me?
Yes, sir, sir. Please proceed, sir.
Right.
Welcome to the FDP of 3 days FDP from Shadan College of Engineering Technology.
Thank you, sir. Thank you.
And from all the participants, welcome you to this program.
Oh,
Thank
thank
you
you,
for
sir.
being here with us, sir.
Thank you, sir. Good morning to all the participants. Myself, Javed, sir has introduced just now. So I am from Sri Datta Institute of Engineering and Science. So without wasting our time, let us directly go to our topic. That's embedded systems and its robotic applications. Generally, we have heard about embedded systems as a theoretical way. We have studied and we have gone through it in a theoretical way, but we don't know that embedded systems in our general lives, it is having a major role. So because 93% of the electronic components what we use at our homes and offices are based on the embedded systems technology. So we just so this is a very research oriented, application oriented domain. Not only in the robotic application, it's having many advanced applications. So we are habituated with the embedded systems. So let us just go through it. What is actually the embedded system is, what are the applications of it, and how a product will be designed using the embedded systems. Let us let's see. So generally, we might have heard about the embedded systems. That embedded system is a combination of software and hardware. But how? Embedded systems is really it's a combination of software and hardware. But how it was become? So here we have shown the software. It's a Keel Microvision IDE integrated development environment, and a hardware which is called the microcontroller. And by combining these two, software and hardware, we will get the application. So either this application may be what number of. Let us see the examples of embedded systems, so that we can understand very easily the concept of the embedded systems. So generally, these devices are used to monitor. We have seen in many movies and like that, someone, if somebody is walking, automatically the lights are going to be on. If no one is there in rooms, automatically the lights going to be off. So these all the type of applications are under the embedded systems. Not only those, generally we use refrigerators and washing machines, air conditioners, televisions, everything. Every electronic component will come under into the embedded systems technology. Just embedded systems is uh, it's a computer hardware with embedding a software into a hardware. So here a code has been written. This code will be embedded into the hardware. So generally we call it as we call it as an embedded system. So this we can easily understand that what is an embedded system. So here we can see that in an embedded system we have few major hardware components. So is it clear now? So a few people are saying the voice is not clear. Now is it clear?
Okay, sir, it is clear.
Right. Okay. So this is generally the block description, block diagram of the embedded systems, the major components of the embedded systems. We will have a sensor. We can't call not only a sensor value. It we can observe. It is an input. Either it may be a switch. For example, I just have kept here the temperature sensor. Not only the temperature sensor, we just give the input. It takes the input and it will give to a processor. So the processor will process and it will give to the control output, that may be a motor, light, or whatever it is output. For example, let us take this only the example like temperature sensor. If in a particular room, like we can take an air conditioner. So nowadays in a previous days, what would have happened, if we switch on the AC, it would have only switch on up to when we switch off it. But now if we set a temperature up to that, after that mark, after the threshold value, the air conditioner will automatically it will be switched off. So if there we will have a temperature sensor, so it sends the value of the temperature in the room. Then after it detects that particular value, then it will give to the processor, and processor will give the air conditioner, whatever it may be, the compressor air conditioner is having, or motor it is having, it will turn off it. So this is one type of application here. So in any type of application of embedded system, we will have a sensor value, that is nothing but a input value, and to process it a processor, and it to control output, it may be a motor, light, and a display, or whatever it might be. To store all this data, we should have a memory, so that processor or whatever will contain a memory. So this is general block description of embedded system. So we have to know here about the input values, the outputs, and the processor. So what are these, all this we let us see the briefly. So a few example let us discuss, so that we can easily understand what is an embedded system. So here, if we consider a refrigerator, the general uh, hardware device what we use at our homes, this a refrigerator, as we have discussed, air conditioner and refrigerator will work as same. So here the temperature, required temperature and actual temperature will be given to a computer, that is a processor, and compressor, its compressor will have it controls, and after reaching the particular temperature, the refrigerator will be in off condition or on condition. So refrigerator is one example of embedded systems. And washing machine, so here we can discuss somewhat deeply. uh, the thing, washing machine, what it has to do is just it has to wash the clothes. And embedded systems generally not only a combination of hardware and software, but it is also a performs only a particular task. So refrigerator is to freeze what we to be cool in the room of refrigerator. That is only its work. And if we consider this washing machine is an as an example, washing machine as an example, it the application of the washing machine is to just wash the clothes. But
बहुत
the
आगे स्कूल ना
but but the thing is, for example, we will have different type of cloths. For example, jeans cloths, cotton cloths, and nylon cloths. Different type of cloths we will have. So if we want to wash these cloths, so for example, if we are giving an instruction to the washing machine to wash a jeans cloth for just for 5 minutes, so whatever the dust in the jeans cloth will not go. If we tell a cotton cloth to wash for 1 hour or 1.5 hour, so it will turn out. So here we have to give a particular instruction that according to the cloth, the washing machine has to be washed, and it has to wash by spinning. For example, rains dry, we can do the drying, and for example, after keeping the clothes in the washing machine, spinning has to start, and it has to spin for 5 minutes. After first, it has to take the water. After taking the water, it has to spin for 5 minutes, and after 5 minutes, it has to take some detergent powder. And after taking the detergent powder, it has to again wash, and water has to remove, and again fresh water has to take. And so all these instructions what the washing machine is having, these all the instructions we have to give to the washing machine. So all these instructions will come under the software. So for this to give the instruction, we will have some languages to process it. To process these instructions, we should have a processor, and here the input will be the switches. Generally in washing machine we use switches. So switches are the sensors. So sensors are inputs. So here, so according to the instruction what we give, the washing machine will have to act like that. So this is a best example of the embedded systems. So here the hardware part will come, the motor. Spinning has to be done by using the motor, and switch is also a hardware, and motor is also a hardware. And to take the water and remove the water, what are the pipes and all those things, whatever it is having, all these come under the hardware part. So instructions, what how to control a motor and how to run it, how many minutes it has to run it, will have the instruction, software instructions. So that's why we generally called uh, uh, embedded systems as a combination of software and hardware. But here we also have to say that it performs only a single task, a particular task. So this is washing machine is one example. So here the car door, generally we use in car door is also one example. So now we might have understood that, so in everywhere we are using the embedded system. So car door, when we lock it, it has to open by just clicking the device, what RF device generally we use. So when we clicking it, it will open and it will lock. So that is also an embedded system. That's a car door. So electronic ping pong, it's like a small game. Okay, LEDs has to glow it. A microchip, that is nothing, a embedded computer vehicle. This is also one example. And here autonomous guided vehicle. This here we have used some sensor here. So according to this sensor, these wheels have to be rotated. This sensor will give input to the controller, the processor, and different type of. Here also we have some sensors to detect the obstacle. According to the obstacle, the vehicle will move. If obstacle is there, it changes its path. So it has to change its path. So this is also one example. So in military applications like that, in military robots, we can use these type of applications. And majorly, according to our topic, the robotics in next coming years, the robotics will play a major role. Embedded systems, artificial intelligence, and with robotics, it will play a major role. So here, a few examples of the robotics. This is a spider robot. So like it's looking like a spider. So this acts as a spider, it moves as a spider. So this is one example of the robotics. Not only that, this is a humanoid robot. So these eyes are the sensors. So eyes we can call as the sensors. These are the motors, servo motors, or different kind of motors we can use here. So according to this sensor, these motors will move. So for this, we will use a embedded processor. This is one example of embedded processor. Let us see those also the embedded processors. So these are the examples of embedded systems. So every in every stage in every stage of our life, when we step into the home, generally the survey says that 93 to 94% of the electronic devices we are using currently are based upon the embedded systems technology. So difference what embedded system can make, can see embedded systems with other. So embedded systems is a real-time operation, and that, as we have seen, washing machine and refrigerators as an examples, and the size of the controller will be very low. This how if we take a microprocessor, uh, because why the size is low is, when we take the microprocessor, when we say a laptop or any personal computer, it should have a RAM, ROM, and hard disk or something. We generally call it as a hard disk. So these are all will be in a separate part in the microprocessor in personal computer. A personal computer or a laptop will do many operations, but here the embedded systems will perform only one task. So for that one task, this is a uh, size inbuilt ROM will be there, inbuilt RAM will be there. So that's why, it is performing only a single task. So the memory also, no need of memory of like 512 GB or 1 TB like that. It has to store only the instructions. So the memory also very less memory will be there in the this embedded processors. Generally, microcontroller is the heart of the embedded processor. Microprocessor is different and microcontroller is different. So here, because of that reason, the size of the uh, device will decrease, and cost, microcontroller cost generally around, and on an average it will be 500, but a microprocessor cost will be a 4,000 or 5,000 like that. So cost is also less, and the time, so once we code it for a particular task, it performs fastly. Generally, when we compare with the microprocessor, it's somewhat slow, but the when we compare, it's performing only a single task, so it will be uh, feasible in time also. So reliability, safety, because only particular task of safety, energy consumption is also very less in microcontroller than the microprocessor, and security, we can apply the security. So all these features for the microprocessor or micro embedded systems will play a major role. So these will be the differences for the embedded systems. We can go to the next that inside an embedded system, we will have the hardware. So because it's a combination of hardware and software. So hardware is the CPU, memory, input-output devices, as we have seen. Software is an operating system, application, and devices. So these are the inside about the micro controller embedded systems. So here, some types of embedded systems are there. So based on performance, functional requirements, there are many different types of embedded systems are there. Different types of embedded systems are there. Performance, functional requirements. So real-time embedded system, we generally made it as a real-time embedded system, standalone embedded system, networked, and mobile embedded system. So based on the performance of a microcontroller, that's embedded microcontroller is nothing but embedded processor. Based on the performance of a microcontroller, it has been divided into small scale embedded system, medium scale embedded system, and sophisticated embedded systems. Let us see. So if we take the real-time embedded systems based on the performance and functional requirement, the first one is real-time embedded systems. Here we can see that examples are the aeroplanes or bullet trains or the robots what we use. So these are all the real-time embedded systems. Real-time embedded systems are uh, depends not only on the logical result. That means not only it depends on the particular point, it will also depend on others also. So when we consider a aeroplane or a bullet train, it has to depend on the lights, the sensors what it shows at the station or something. Automation if we consider. So these will depend upon other things, avionic controls, banking systems, and videos, uh, software real-time systems. These are also somewhat types in the real-time embedded systems. So real-time embedded systems means it will not depend on a particular point. It will also depends upon the other strategies also. So when we take the standalone embedded system, so these are a few examples. So air conditioner, refrigerators, and these once we install it, so it will not change. It will not change. So it will be like that only. TV box or so all these will come under the standalone embedded systems. So networked embedded systems will come on what we use the internet. So for local area networks and WANs, for the switches to connect it, the to internet to connect it. So how to divide the internet? So through a switch, we can divide the internet to many points. So here, so to which point how much MB it has to go, and to which point to 20 MB, 10 MB, whatever it is. So that has to be divided. That has to be decided by the switch or any hardware device. So we can use generally we use less embedded system in the network. Yeah, but this also we can use. This is one more type of network embedded systems. So here, another one is a mobile embedded systems, which can move from one place to another place, like mobiles, cameras, personal things, cell phones, mobiles, digital cameras, MP3 players, where we can move from one place to another place will come under this mobile embedded system. So this is one of embedded systems type. So based on the performance of micro controllers, so there are in microcontrollers we have different types: 8-bit microcontrollers and 16-bit and 32-bit. Nowadays 64-bit microcontrollers are so available. So here in small scale embedded systems, very few 8-bit or 16-bit microcontrollers we will use. Just by using a small 9 volts battery, they will enable. So these will call as a small scale embedded systems. So using language, a small language we can use. Uh, C language we can, a small scale embedded system can be designed through the C language. So when medium scale embedded systems comes, so here it will depend upon the RISC architecture, uh, reduced instruction set. So there are RISC and CISC architectures also there for the microcontroller. So here mean medium systems up to the 32-bit microcontrollers we will use. By using the 32-bit microcontrollers, we will design the applications or any product. So in embedded softwares, C, C++, and Java, Python also we can use. RTOS, real-time operating systems, all will come under the medium scale embedded systems. So here another one is a sophisticated. So here it's somewhat different type, the combination of programmable logic devices. So ASICs and all will come under in the sophisticated embedded system. So some generally somewhat different than other two embedded systems technologies. So these the 7 types uh, in embedded systems. So these is about the embedded systems, different types of embedded systems. So if we go to the applications, examples we have seen, applications are industrial machines, automobiles, medical equipment, cameras, household appliances. So all these will come under the embedded systems technology. So as I said, 93% of the electronic devices we are using the embedded systems technology. So embedded systems in consumer electronics, digital cameras, set-up boxes, DVDs, everything will come under the embedded systems. Here motors, engine safeties, body of the vehicle, robotics in wireless communication, mobile computing. Here also smart cars, missiles and satellites. Everywhere embedded systems we are using the embedded systems. So peripherals and computer networking in image processing, also we are using embedded systems. So if we see general digital circuit and a microprocessor or microcontroller based system, so these are the differences. When we go to the microcontroller, those are all flexible, but these are all, as I said, these are microcontrollers somewhat slower than the other digital circuits, but only we are using only one combination, one particular task, so it will be useful only. So examples, communications and will come under the digital circuits, and for personal computers, mobile phones will come under the embedded systems. So now uh, we are talking about the microcontrollers. So generally, microcontrollers we are using processor has to play a high role, and it is a heart of the embedded system. So let us have a glance on what are the microcontrollers we have, what are the processor embedded processors we have. So here these are the types: micro computational micros. Those are 32 or 64-bit data bus. Generally RISC processors will come under these. So portable, these are also the portable devices, so we can move from one place to another place easily. So general here General purpose micros are the 32-bit microcontrollers, advanced RISC machines, PIC microcontrollers, are something will come under these general purpose microcontrollers. So this one is we generally call microcontrollers, which are 4, 8, and 16-bit data bus. These will contain so memory, input, outputs, peripherals, everything will be uh, having in the microcontrollers. So domain specific processors for DSPs and for image processing for networking, we will have some different kind of processors like Raspberry Pi, Arduino Mega, or these are the different processors we use for various domain specific based on domain specific processors. So generally, a microcontroller is an it's a integrated circuit. It can be programmed through the instruction sets by using C language, by using assembly language, by using Java, by using Python. We can give the instructions to that particular hardware we call as a microcontroller. It will have inbuilt a processor, inbuilt memory, inbuilt input output, and it we can easily program it. We can give instructions very easily to the microcontroller. So these are the examples of microcontroller. I just have taken the big microcontroller. So here different types of different families of the microcontrollers, different with different pins, which contains input output pins, so that we can connect uh, any sensor or any motor or any other devices to these pins to perform. So here microcontrollers have been divided on bits based 4-bit, 8-bit, 16-bit, and 32-bit. When these have been under the memory devices, embedded and external. That means inbuilt memory will be there, and as well as we can connect the external memory if we need uh, some extra memory. For example, in 8051 microcontroller, generally we have studied in the academics. In 8051 microcontroller, we have only 4 kilobytes of memory. So 4 kilobytes of memory is very small one. So we can't for small applications like washing machine and a refrigerator, it is having a less instructions, so we can use the inbuilt embedded memory for those applications. But for example, if we consider a cricket game, for first innings and for second innings, a batsman how much it has scored, and it has to compare with in second innings, it has to compare with the first innings, how many balls bowled, and so all these will the huge data is there uh, for uh, for a cricket scoring display. So there we should have some extra memory. 4 kilobytes of memory may not be sufficient there. So we have to use some different some more memory. So those we'll call the external memory. And based on the instruction set, microcontroller also divided as CISC and RISC. So on the memory architecture also, Harvard architecture and von Neumann, generally Princeton or von Neumann architecture. So these also divided like this. So in the microcontrollers, the family, Motorola, National Arm, others. In others also, we will have different microcontrollers and like AVR microcontrollers and PIC or different microcontrollers are there in the field now. So these are few companies which are manufacturing the microcontrollers. So 4-bit microcontroller is generally the bus size in 4-bit microcontroller. It will have 4-bit operations. Only instruction set width bus width is 4-bit for 4-bit. So in 8-bit controller, we know that the bus will be 8-bit address bus and data bus. Every bus will be 8-bit. In 16-bit microcontroller, uh, so here it is 16-bit data bus, address bus, and all the buses will be in 16-bit. So according to memory devices, internal memory will be there and external memory will be there. So embedded microcontrollers 8051 having program and data of mode. So it is having some 4K of internal memory. So when we call the external memory, so whatever, not only 8031, 8051 or whatever it is, if memory is not sufficient, we can connect somewhat extra memory through EEPROM. We can connect EEPROM. In 8051 we will have pins, external access, program store enable, and one more ALE, address latch enable. So through these pins we can connect the external memory. External memory we can connect. So if memory is not sufficient, so internal memory will be there and also the external memory will be there. So this is an example EEPROM. So CISC processor based on according to the instruction sets, complex instruction set is one architecture microcontroller and also the RISC processor. So 8051 microcontroller is a CISC architecture and ARM advanced RISC machine is based on the RISC architecture. So here one more architecture difference is based on the memory von Neumann architecture. In von Neumann architecture, data, program instructions and data stored in a common memory. But in Harvard architecture, the data memory and the program instructions will be stored in a different memories. That is a small difference between von Neumann architecture and Harvard architecture. So generally, von Neumann architecture is a simpler way. So this is example of von Neumann architecture. So here, memory data memory will be in a. So here we can see the spaces are different. So in Harvard, this is a Harvard architecture. So in Harvard, sorry. So in hardware architecture, separate data bus and an instruction bus will be there. But in von Neumann architecture, the memory will be different. So when we compare with von Neumann architecture, the Harvard architecture will be faster because the memory and data buses are different. Sorry, not memory, instruction bus and data bus are different. So this will be uh, fast, but memory has increased. Two memories we need to keep, so automatically the complexity of the circuit will increase than the von Neumann architecture. So these two architectures are important in the microcontroller, von Neumann architecture and the Harvard architecture. Just a simple difference is the data memory and the instruction set memory are different and in combined. So this is general microcontroller architecture. Either it may be von Neumann or Harvard architecture. It will have some ports. So generally in some microcontroller we call as a port 0, port 1 and port 3. In some microcontrollers we will call as a port A, port B and port C, like that. So for external memory EEPROM we can connect program counters, stacks and all these will be there in the microcontroller architecture. So central processing unit, arithmetic and logic unit, oscillators, oscillator to give a particular frequency to the microcontroller. For 8051, it's 11.092 megahertz. Like that, for every microcontroller, we have to give a frequency so that it can synchronize the input, output, and other pins, and everything will be synchronized with the same frequency values. So read-only memory we will have for different controllers. Different memory will have. So random access memory, special function registers will have. So for the special function registers, if we want to connect wireless devices like GSM or GPS, Bluetooth, so we have to enable the special function registers of serial control. So in general 8051 will have serial control, but for others they will have some other special function registers. Not only this, for interrupts, for timers, for everything there will be a special function register should be there uh, for wireless devices like GSM and GPS, Wi-Fi. If we want to connect a Wi-Fi module, so special function registers are also important in a microcontroller. So registers also there, input output ports, counters, timers, and other peripheral devices also, analog to digital converter, digital to analog converter, watchdog, timers. All these will be present in the microcontroller. So performance of a microcontroller depends upon its usage, its power source, its analog to digital converter, and its a set of input output ports to which port we will connect input and output sensors. So how to connect those? Also, let us see. Let us see with an example uh, tomorrow. Now we are discussing only about the theoretical part. So power source we have to give, how to enable them, how to disable them. Let us see. So if ROM, so applications already we have seen. So to choose a microcontroller, criteria for choosing a microcontroller, the speed we have to check, the package we have to check, how much power consumption. Some microcontrollers will take 5 volts, some microcontrollers will take 3.7 volts. So how much RAM is there, how much room is there, how many input output pins are there. So all these we have to check and select, choose our particular microcontroller for our particular application. If it is a high-end application, if we use the 8051, it's switch. If it is a small applications, if we are using like Arduino or Raspberry Pi kind of processors or controllers, so it will be somewhat different. So we have to check the cost also. We have to check the cost. We have to check the power consumption. Everything we have to see, check, and we have to choose a microcontroller for our particular application. So these are a few companies who are making the microcontrollers: Atmel, Philips, AMD, and so many companies are there who are supplying the things. So this is about the processor microcontrollers. So tomorrow, let us see about the 8051 microcontroller and Arduino, how to give instruction with a sample. Uh, and today, let us discuss one more component. So we have in embedded systems, one is input. So sensors should have as an input, and processor should have, and output in output the motors or something should have. So we have seen about the processor microcontrollers just in a brief, and as a sensor, we sensor can't be say one type or this particular type or that particular type. A sense. So sensors are the different types. It has to measure a physical quantity. For example, temperature sensor is there. It has to measure the temperature and give the value to us. If a fire sensor is there, if fire sensor, it has to, and if fire occurs, it has to sense the fire. So different type of sensors we have in the market. According to application, we can choose the sensor. These are the common type of sensors. Not only these sensors, but also there are a lot of sensors available in the market. Here, I'm just concentrating on some commonly used sensors. So temperature, light sensors, magnetic sensors, ultrasonic, pressure sensors. So these are the sensors what we use. So temperature sensor generally it gives a temperature value. Generally we use in engines, so in chemical processing or in air conditioners, in refrigerators we use the temperature sensors. So light sensors, laser light, we can say that one example of it, infrared detection and the other lighting applications. So magnetic sensors will be used in power steering in vehicles. So in power brake, power steering, so to transmit the data, so magnetic sensors will be used. So ultrasonic sensors will be used to detect the position, range. This is one type of sensor. So proximity sensor can be used. For example, we are using proximity sensors in vehicles to detect if any accident occurs. Airbags has to open. Message has to if any accident occurs, message has to reach to that's family members or something. So in these type of applications, proximity sensors will be used. So these proximity sensors will detect when the accident occurs. So in within a fraction of seconds, um, the airbag will be opened. So those type of applications, proximity sensors will be used. So in like biosensors, ECG, we generally test how much in water, what are the chemical contents are present in the water. So biological sensors also available in the market. So sound sensors, image sensors, all these type of sensors will be we can use as an input to the processor. So these are the sensors we use in the embedded systems. So we have seen uh, applications of the embedded systems. What is an embedded system? Applications of the embedded systems, and about the microcontrollers, which is a heart of the embedded systems, and the input to the processor, microcontroller sensors. So these are general things. So tomorrow, let us take an example, and we will concentrate on the uh, real-time application, how to write the code and how to flash it and all those things. Let us concentrate tomorrow, and day after tomorrow we will have a last session on the robotics, robotic, particularly on the robotic applications with embedded systems, how we are using the robotic applications. So this is our flow. So for today, if are having any questions, you can type in the chat box. I just answer it.
Javid sir.
Yes, sir.
Okay. Participants, if you have any doubts, please you can type in chat box or you can unmute your speaker and you can speak. If no one has any doubts, we'll conclude the session for today. And tomorrow, as Javid sir has said, we'll see practical explanation. Today you have learned the theoretical about embedded sensors, different types of sensors, where we are using a practically. And tomorrow we'll focus on practical. And Sunday we'll see about the robotics. Many participants are requesting through email and through mobile. You didn't get email or any types of error, etc. I request you all once again, please check whether you have entered correct email ID or not. Because when I think once again, when I going to cross check once again, they have entered the email IDs wrong by typing mistakes. Some entered gmail.com instead of gmail.com, some entered gmail.con. Very few entered and gmail.com means hmail.com. Some typing mistakes were there. So please once again check your email ID. And whoever registered till yesterday evening, I have mailed participants link to all the participants. Today I didn't check new participants. So till yesterday who are registered, they all got the participation link. And tomorrow at the same time at 10:30, we'll join with the same link, same ID, Zoom ID. On Sunday, after completion of the session, maybe afternoon, we will issue one feedback form. Whoever fills the feedback form, then only they will get the e-certificate. Please make sure that your attendance here is definitely will consider, but feedback is mandatory to get the e-certificate. And one more good news is soonly, maybe from next week onwards, we are going to conduct another FDP. So we'll let you know the details on Sunday from EC Department, Shadan College of Engineering Technology. Okay, one person is asking how attendance taken. Definitely we'll see how many people have attended. We'll get to know all the details. One Junaid person is asking, we'll take care of that attendance. Please, you no need to worry. Okay? And once again, I thanks our resource person, dynamic faculty, Mr. Javid, and to all the participation who spared their time on holidays and lockdown period. From EC department, my team, and from my college chairman, principal, Dr. Atikur Rahman, chairman Shah Alam Rasul Khan, from all Shadan family, I thank wholeheartedly to all the participants and to our eminent speaker, Professor Javid sir. Thanks to one and all. We'll see tomorrow at 10:30 a.m. If any
Sir,
still, you can mail me on my email ID, ilyas.ec@gmail.com.
sir, my question, sir, Ilyas, sir, I am Dr. M. Satyanarayana.
Okay, tell me, sir, please, sir.
Feedback form you will send online, sir.
Yeah, online only, sir, to email to your email ID. Maybe on Sunday I will send, sir. End of the session.
After completion of all the program.
All the sessions, sir. Because today is the first session.
Ah, yes, sir. Yes.
Okay. On Sunday I will send the feedback form, sir.
Thank you, sir.
Okay. Okay. Any doubts from any participants? Okay. We'll conclude the session. Thanks to everyone wholeheartedly. Adan family. Have a nice day. Stay safe. Stay home. Thanks to all. Thanks to Javed sir.
Thank you, sir.
We'll conclude the meeting, sir. We'll leave the meetings.
Oh.
Okay. Thanks to all.